Good morning, everyone. This is Saujanya, Assistant Professor, CSC Department at GRIT. Today I am going to explain about the system models for distributed and cloud computing. Distributed and cloud computing systems are built over a large number of autonomous computer nodes. These nodes machines are interconnected by different types of network connections like SAN, LAN, WAN in a hierarchical manner. A WAN can connect many local clusters to form a very large cluster of clusters. Many national grid built in the past decade were underutilized for lack of reliable middleware or well-coded application. There are different types of distributed computing systems are there. Those are classified into four types: cluster computing, peer-to-peer networks, grid computing, and cloud computing. Here, first one we are going through the cluster computing. We know that cluster is nothing but a group of similar type of nodes are connected together. Those we are calling as a cluster computing. This cluster computing consists of interconnected standalone computers which work cooperatively as a single integrated computing resources. This diagram showing that how the clusters are connected in a single place. Right here, different types of servers are there. These we are, if whenever there's different nodes are connected together, that we are calling as a cluster. Where here different types of network connections which we are using to connect this all the servers. Then each and every node is having the I/O devices and disk arrays like that. So this is the gateway. We are saying that this LAN, SAN, WAN out the internet, right? So we are using the gateway also here. This figure shows the architecture of a typical server cluster built around a low latency, high bandwidth interconnection network. The network of computer nodes are connected by a LAN, SAN, or WAN. They are typically homogeneous with distributed control running Unix or Linux. They are suited to HPC. HPC is nothing but high power computing systems. Next one is the peer-to-peer network. These peer-to-peer networks are interconnected as a standalone computers which work cooperatively as a single integrated computing resources. Right? The P2P architectures offer a distributed model of network system. In these peer-to-peer networks, each system will be connected to each other, and each data will be shared by each system, right? That P2P system. The diagram shows that how the P2P systems are connected to each one. These are the systems, nodes, these are the routers or something which will be connected together. Each system is connected to the other one. Please check here. Physical link will be there. Each and every system will be connected to the other one. In a P2P system, every node acts as a both client and server, providing a part of the system resources. Peer mechanism are simply client computers connected to the internet. All the client machines act autonomously to join or leave the system freely. They can easily join the system into this connection, or else they can directly leave from the system freely. Right? In a P2P network, every node acts as a both in the both client and server. Just now we learned this point also. Feeds act autonomously to join or leave the network. No central coordination or central database is needed here. No peer machine has a global view of the entire P2P system. The system is self-organizing with distributed control. Unlike a cluster or grid, a P2P network does not use dedicated interconnection network. Please note this point. Next one is the computational and data grids. Grids are heterogeneous clusters interconnected by high-speed networks. They have centralized control and are server-oriented with authenticated security. They are suited to distributed supercomputing. The grid is constructed across LANs, WANs, or internet backbones at a regional, national, or global scale. The computers used in a grid include servers, clusters, and supercomputers. PCs, laptops, and mobile devices can be used to access this grid system. Please see this diagram. This diagram shows how the grid will be connected. These are all are the system, different types of devices we can connect it through the grid with the by using the internet. High speed internet networks are used here, right? This is the database, and these are the system which will be connected. IP broadband, LAN, WAN, or anything we can connect here. Right? This diagram shows that computational grid or data grid provides the computing utility data information services through the system. Next one is the last one, cloud computing. A cloud is a pool of virtualized computer resources. Workloads can be deployed and scaled out quickly through the rapid provisioning of virtual machines. Virtualization of server resources has enabled cost effectiveness and allowed cloud system to leverage low cost to benefit both users and providers. Here, cloud computing applies a virtualized platform with resources on demand by provisioning hardware, software, and datasets dynamically. See here, you know that the cloud definition. Cloud is providing the services, applications, data, infrastructure as a service to the end user. Here, see here, here is the user, and whereas the paid services is there as well as the free services is there. Whatever the services needed by the user, those services are provided by the cloud, like hardware, storage service, and network as a service, software as a service. What the user needed, first he need to submit one request, then whatever that he need the user services, that will be sent to the user, as maybe it is a paid service. Sometimes it will be free, sometimes it will be the paid services will be there. The diagram shows that virtualized resources from data centers to farm and internet cloud provisioned with hardware, software, storage, network services for paid users to run their applications. Thank you very much.